All right, so in the last lesson, you should have worked through these three different labs with some of these resources. And in your notebook, hopefully you've recorded the data from each of the three labs. At the end of class, you should have grabbed a blue paper like this that you can use to now draw graphs of the data you collected and then answer some questions. So, what I'm going to do is just lead you through this because that's the lesson that you're going to try and complete. Okay. I'm going to use the white paper instead. Just it's a little bit bigger and clearer, but you should have that. All right. So just as a quick review with Lab A, you were looking at this question where you had, so Perry had 36 square tiles. He was trying to use the different tiles to make a hot tub. You use little squares to figure out how many rectangular configurations you could come up with. Okay, so if I go back, here was the resource to the tiles you could have used if you needed them. But how many arrangements of 36 tiles could you make? You could make a 6 by 6. You could um, take some of these tiles and move them around and possibly come up with, um, let's see, so you could have had length of 4. So 4 by 9, 6 by 6, 1 by 36, etc. Okay, go ahead and write the different widths and lengths that you came up with in your table over here. Okay, were these some of the pairings you were able to find? A 1 by 36, 2 by 18, etc. Okay, so next I want you to go ahead and take these and graph them. This is the width and this is the length. So go ahead and plot dots to make a scatter plot. Okay, so how did that go? We should have ended up with having the dots right here, kind of making a scatter plot like that. Okay. All right, so next what I want you to do is look at your graph and go ahead and answer question 1. I want you to try and describe it in words. Okay, so there's lots of different things you could have said here. You could have said, well, it's nonlinear. You could have said it's curved. You could have said that as the length increases, or sorry, the width increases, the length decreases. Okay. So what else could we have said? So lots of different. So some people may describe it by the shape. It looks kind of like L-shaped, sort of. Okay. So just a couple different words to describe it. If you were in Math 8 Honors last year, you might remember that this is actually a relationship that's called inversely proportional. Okay, so or inverse variation. Okay, but you don't need to know that yet, just maybe if you were there from last year. Okay, so if width were the input, so tying this back to the lesson 111, and length were the output, see if you can come up with a function rule that if you knew the width could help you find the length. Okay, so there's lots of different things that you could have maybe come up with, but did you notice that if you knew the width, you could have predicted the length, okay, by taking 36. So the rule could be the length is equal to 36 divided by the width. And I bet some of you guys figured that out. Okay, now we're going to look at Lab B. So Lab B was a all too relatable virus problem where we had a town that had on day 0 2 infected citizens, and they figured out that each day um, a sick person could infect 2 additional people. Okay. And here was the resource you could have used to come up with some of your data. Um, so let's say if these were the 2 sick people, okay, on day 0, they could have infected 2 others, so that on the first day we'd have a total of 6 infected people. Okay, then each of these people could have infected 2 others. So this person could infect 2 others. This person could infect 2 others. And 2 others. Okay, this person over here could have infected 2 others. And I think that's my last person could have infected 2 others. Okay, and hopefully you saw that there were now 18 infected people. Okay, so go ahead and complete the rest of the chart. Okay, so hopefully you saw the pattern was tripling. Okay, came up with those numbers. So next, what I'd like you to do is to graph as many of those coordinates as you can. Okay, so you probably saw with the way that this was growing that you couldn't fit too many coordinates on there before the graph was too small. So the next, what I'd like you to do is to describe your graph in words. Okay, so some of the things you could have said maybe were that it was nonlinear. It looks like the dots have a curve to it. You could have said that as the day was increasing, the number of people, infected people, is also increasing. If you were in Math 8 Honors last year, you might have heard that this term was exponential. Okay, this function machine is going to be pretty tough to come up with. So I'm just going to leave this as a blank one and see if you can get it. If you can't, no worries. We'll talk about it when we get back together. Okay, so let's look at Lab C. So in Lab C, what you were supposed to have done is do some timing for how long it takes to write a signature. So you were supposed to write your first name twice, then 3 times, then 5 times, then 7 times, then 10 times, and record it. Okay. So obviously, students have different lengths of names. So the time involved is going to vary depending on what your name is and how fast you're writing. Okay. But go ahead and in the table, put the data that you collected. So the 2, 3, 5, 7, and 10. Okay, so obviously this could be different based on the name, but here's a recording of what I'm going to use. So then I'd like you to go ahead and plot that on your graph. Okay, and depending on how fast you're writing, maybe you could fit all of it on, or maybe you couldn't. So I could only fit 4 of my data points on here. So now I want you to go ahead and try and describe this graph in words. All right, so here are just a few of the things you could have said. It's almost linear, okay? So if I were to go ahead and put a straight edge down next to this, it'd look pretty close to being linear, okay? And it is almost proportional because in addition to being linear, 0, 0, if you had 0 signatures, the time would take 0 would also be kind of a data point in here. So you might have remembered that term from last year. You could have also said that as the number of signatures increases, so does the time. All right, so then what I want you to do is to try and come up with a possible, a possible function machine that this could be. Okay, for mine, it looks like approximately, but not exactly, that the time was going to be 3 times the amount of signatures. Okay, so it looked like the unit rate was almost 3. All right, so next what I'd like you to do is take a look at the questions on the back and go ahead and answer all 4 of these. Make sure that you got this paper in a safe place because we're going to start our next class together with working or sharing these ideas with each other. Okay, so hopefully the lesson today You start to see that if you can look at a relationship, make a table of values for it, make a graph for it, and you can start to then interpret by taking that visual and connecting it with the story. You can maybe find out some more things about what that relationship. So kind of like what we talked about with that brain science on the first day of class.